In this video, we're going to talk about edge data pipelines. What is it? What AI applications it supports? And what are some important qualities of edge data pipelines? So first, the definition of a edge data pipeline. It delivers essentially high quality data from edge data sources like machines, instruments, sensors, historians, SCADA systems, files, software APIs to the cloud. And through the process, typically the data needs to be processed through a data engine. For example, cleansing, validation, transformation, contextualization, event extraction, anomaly detection, many different kinds of data processing. And what comes out of the data engine is high quality data. This high quality data then gets deposited into a data warehouse, which can be Snowflake, Databricks, Azure, Amazon S3, time series databases, different type of data warehouses. And now that data can be used for modern data applications. A lot of those modern data applications include AI today. So some examples include, for example, using vibration data to predict machine failures days or weeks in advance. We're using electric current data to predict welding equipment failures and predict their quality. Sometimes it's not about, preventing downtime with predictive maintenance. Sometimes, for example, it's about analyzing the root causes of the equipment design issues so that future designs can be better. And sometimes it's about predicting component life cycles through the entire life cycle, not just close to the time of failure. So in addition to AI applications, a lot of BI applications also use edge data pipeline data extensively. So once you have those component lifecycle models, you can also predict or analyze which component brand is better than other brands. That helps you to select what components to buy. And very often when it comes to modern data applications, it's not about a single site. It's almost always about analyzing all the sites. So now you can analyze KPIs to understand which site is performing better, what are the reasons it's performing better, and how do you improve the sites that are not performing as well. So when it comes to edge data to support this type of applications, a lot of times you require pretty high speed and high volume data. This is because AI gets better when there are more signatures in the data. So when you have high speed data like vibration data and current data, there can be a lot of interesting features and signatures in those data. Similarly, the more data you have, the more likely that you're going to have more signatures, which improve the AI models. And typically, edge data has so many different type of protocols and formats. Quality has issues, and therefore you need a lot of processing to prepare the data. This is more processing as compared to, say, the enterprise structure type of data. Therefore, that data engine implementation is pretty important in edge data pipelines. Event extraction is also very common. This is because a lot of the edge data is time series data. And when the equipments are operating normally, the data may not have a lot of value. So you don't necessarily have to send all the data to the cloud. You can just, look for events in the data and only save the data that's relevant, that's important. And that's event extraction, and some event extraction algorithms can be quite complicated. So I often get asked question, how is the edge data pipeline different from a traditional data system like a SCADA system? A SCADA system is really for HMI type of applications, right? Serving humans, looking at what's going on. While edge data pipeline typically delivers data that's used for AI, which is really, much more advanced data analytics, requires much more data. And so there's a higher requirement on what edge data pipelines need to do to deliver those type of data. So what are some good qualities of, edge data pipelines? We can understand that through a couple of examples. This is one where a customer uses high-speed sensors to predict machine failures. Those sensors can include vibration sensors, but there's also sensors like flow sensors, temperature sensors. There's sensors that are analog. There's sensors that are digital. So you have to support high-speed sensors, many different type of sensors. And this setups are deployed in many, many locations. And so the entire process has to be automatic. You cannot manually set up each hardware system in a lab and ship it out. You basically ship standard components out. And you expect that customers would plug the sensors in any way they want. And therefore, the sensors need to be automatically recognized, configured. The customer's data workflow needs to be automatically recognized and configured. Everything has to be plug and play. And in addition, a lot of times the data comes up through cellular, so now you want to have very reliable cellular performance in terms of data coming up, stored forward. And you wanted to find ways to reduce cellular cost by dynamically configuring what data to send, what data not to send. So it's a very complex solution once it scales up, and a good data pipeline needs to be able to support all those features. A second example sort of goes in a slightly different direction. Here, the edge data doesn't directly come from the sensors. They come mostly from databases like the PyHistorian, Snowflake, SQL database, or a web API. But the data still needs to be prepared, cleaned, and transformed into unified high-quality data. In this case, the amount of data is huge. Every single machine is blasting data. And in the second half of 2023, we processed over 600 million rows of data, and that number continues to grow. So this puts a lot of demand on the data connectors that are getting data from the data sources, but also putting data into the data sinks. The data connectors needs to work at high speed, ingest a lot of data, and therefore the design of those connectors are pretty critical. In addition, with that volume of data, you cannot process that in a single computer. So you need to be able to parallelize the processing through many, many virtual machines in order to support this type of system. And finally, a lot of data processing is done to reduce the raw time series data into events. And we were able to essentially reduce the amount of data by a factor of 70,000. So now the output data are just events, and it's a much smaller data set. It's much easier to be used by AI and digital twin type of applications. So this is a system where a lot of data processing goes into the edge data pipeline. So to summarize, a good edge data pipeline has three characteristics. The first one is high quality data, reliability, and security. The second one is scalability. You want it to be able to scale to high speed data, high volume data across many, many locations automatically. Otherwise, the edge data pipeline would not work at scale. The third important characteristic is flexibility. Because there's so many protocols on the source side, on the sink side, in the communication protocols, also in terms of how you configure different groups of devices, different groups of sites. Edge data pipeline really requires a huge amount of flexibility, and therefore your edge data pipeline architecture should be able to support that. With a good edge data pipeline, you can speed up AI, and digital twin solution development, and it serves as the foundation to modern data applications. Thank you for watching this video. If you have any questions, please feel free to reach out to us. Thank you.